Alright, this is part 2 of section 3.2. We're trying to find the domain of this function, 2x plus 1 divided by the square root of 5 minus x. So when you've got a fraction, first of all, you set the denominator equal to 0 because that's what you don't want it to be. And since you've got a square root, you set the inside greater than or equal to 0. So first I'm going to start with the bottom. I'm going to set that equal to 0. And I'm going to solve, so I'm going to square both sides. Okay, so 5 minus x equals 0. And I'm going to move x over. So 5 equals x. So that means that x cannot be 5 because we set it equal to the thing that we don't want it to be. And then the inside of the square root has to be greater than or equal to 0. And I'm going to move x over. So we've got 5 greater than or equal to x, and I'm going to switch that around so x is less than or equal to 5. Notice that the smaller side of the inequality is pointing towards x, and same thing here, the smaller side of the inequality is pointing towards x. So now we need to combine these two. Okay, so say we put it on the number line. So here's 0 and here's 5. Okay, so x less than or equal to 5 looks like it's a filled-in circle, and we're going this direction. Okay, that was this part. But over here, x cannot be equal to 5. So what we have is, let's erase this part, we have an open circle. Okay, so combining those, what we really have for our domain is x can be less than 5, but it can't be equal to 5. Okay, so x can be less than 5. So in interval notation, it can start out at negative infinity and go up to 5, but not including 5. Okay, now let's look at something that you've got two square roots, one in the top and one in the bottom. So I'm going to work with the bottom first. So we know that the bottom cannot be equal to 0, so we'll set it equal to 0. We're going to square both sides, so x minus 4 equals 0. So x equals 4. Okay, there's the first part. And then the inside has got to be greater than or equal to 0. So I'm going to move 4 over. And then the top part, x minus 6, that has also has to be greater than or equal to 0 because this is square root. So x has got to be greater than or equal to 0. Now we need to combine these, and let's do it on the number line. So we've got here's 0, here's 4, and here's 6. Okay, so x cannot be 4, that's what we found. X is greater than or equal to 4, and whoops, that should be 6 right over here. X is greater than or equal to 6. So let's take this one first. X is greater than or equal to 4. So we'd start here with a closed circle, and then we would go out this direction. Okay, now let's do this one. We would start at 6 with a closed circle, and we would go out this direction. And now this one, x cannot be 4, so we need to come back to right here and say, well, I need an open circle, but still go in that direction. Now, what we have here is we need to combine these together. So this is essentially an and inequality, which means we need to find where this overlaps. So where I have both colors, that starts at 6 and it goes out to infinity. Okay, so x greater than or equal to 6, Or we can say, okay, we're going to start at 6 and include 6 and go out to positive infinity. That would be the domain for this one. Okay, let's find the domain and range from graphs. Okay, so the domain refers to the set of possible, basically, x values, and the domain of the graph consists of all the x values shown on or all the inputs shown on the x-axis. The range is basically the y values, or all the values shown on the y-axis. Okay, keep in mind that if the graph continues beyond the portion of the graph that we can see, then the domain and range may be greater than visible values. Or if it has an arrow, like this one right here. So we're going to find the domain and range of this graph. So I'm going to highlight. So to find the domain, I'm going to look at the x-axis here. Okay, so looks like it is starting at -4 and going to positive infinity, because this is positive infinity for x. Over here, this is negative infinity. For y, this is positive infinity, and for y, this is negative infinity down here. Okay, so it looks like it is starting at -4, and the graph keeps on going. So it keeps on picking up this number, this number, this number, this number, and it keeps on going way out here beyond what we can see. Okay, so the domain starts and includes -4, and it goes out to positive infinity. Okay, and then let's take a look at the range. Okay, so range would be your y values. Okay, so looks like it's starting right here for your y values. There it is right there. Okay, so it starts at 0 for y and includes 0. And it keeps going up, 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 up. This graph keeps going up, 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 up. It'll keep hitting all of these y values, so it goes to positive infinity for this graph. Okay, now this one, okay, so domain. So our x-axis here looks like it starts at -3, but notice I have an open circle right here. Okay, so it starts at 3, it ends at, looks like 1, and notice right here I have a closed circle. Okay, so for -3, I have an open circle, so I have parentheses. And then for 1, I have a closed circle, so I will have brackets for this one. Okay, range. Get rid of this. Now we're looking at our y-axis here. Okay, so this graph looks like it starts at y equals 0 and ends at y equals -4. And same thing, we will have, for the 0, we had an open circle there, so it's not including that 0. And for the -4, it has a closed circle there, so we would have a bracket for the -4. Just so you can see it, there's our -4. Okay, that's where our graph is ending. Okay, for this one, okay, so we need our x-axis here. And actually, I do need to go back to this one right here. I made a little mistake. You always want to write the lowest number first. So this would be a -4, 0. Okay, so we have the numbers right, but you always want to write the smallest number first. Okay, so now let's look at this one. Now I can't say that, alright, look, it starts at 6 and it goes all the way up to, -6, and it goes all the way up to 6 because we have a break right here. Okay, so the function's not continuous from -6 all the way up to 6. So what I have to do is break it up just a little bit. So this little function right here I need to look at, and then I'll join it with this function over here. Okay, so let's first look at this one right here. So it starts at, and it shows us, and it's got a closed circle, -6, and it goes up to about right there, and it tells us that that's -1/6. And we also have another closed circle. So we will have -6, comma, -1/6, and I have two brackets because I have closed circles there. And then we're going to union or combine it with our other graph over here. And we'll see where the x values are there. Okay, so it looks like right here, and that says that's 1/6, and it ends at 6. Okay, so, and I have closed circles on both of these. So let me move all my markings so we can see that. Okay, closed circles on each one of these. Closed circle, closed circle. So I'll have 6, comma, or sorry, 1/6, comma, 6, and brackets on both of those because of the closed circles. Okay, and then let's look at the range. And same thing, we're going to have to break it up again. So we'll look at this first one right here. So for the range, looks like it goes to, and it tells us right here, -6, or -1/6. And I have brackets there because of that closed circle. And -6. So actually, the -6 is a larger negative number. Let's see. Yeah, it's a larger negative number than -1/6. So it actually makes it smaller. So I need to put that one first. So -6 up to 1/6. And then we're going to union that with, okay, so we've got from here to here. And looks like this is 6. I need that second one, 6. And going to, so that's where this function ends for the y value. This is where this function ends for the y value here, 1/6. So I need a smaller number, so 1/6 up to 6. Okay, now let's look at this one. Okay, so our domain. So we gotta look at our x values here. And it looks like it's about what is that, -2.5. Because if you bring this down to the x-axis, about there. So that looks like a -2.5 for this one. And I'm going to write that up here for right now. And then looks like it keeps going. I have an arrow here. So it keeps getting bigger and bigger, bigger and bigger, bigger and bigger and bigger and bigger. So that means that it'll pick up this value for x, and this value, and this value, and this value, and this value, and you'll keep on going. Okay, so, and I also have an open circle. So I have parentheses, so -2.5 up to +infinity. Okay, and then our range, so let's get rid of all of this. Okay, so now we're looking at our y-axis. Looks like it starts here, and it will go up because of this over here. It'll keep going up for a y. So it looks like it starts at, was that -4? Let me erase this. Yeah, it looks like -4. Yeah, -4. And it includes that because of the closed circles right here at the bottom. Yeah, you got one here and here. Okay, so we'll have a bracket there, and then we're going up to +infinity for our range.